In this lesson we will be looking at polar coordinates. I want you to think about polar representing maybe the world in latitudes and longitudes. Perhaps you've seen those types of maps flatten out. You may have also covered this topic in a trigonometry class. A lot of students get confused because it's literally going in circles. So we're going to go step by step. The polar coordinates are given in terms of r and theta. That's why it's confusing, because that's not really how we should plot them. Now r stands for the radius, meaning how far from the origin, which we will call the pole, should we go out, and theta is the angle, of course, that we're going to rotate through. Another confusing thing is that r can be positive or negative in polar coordinates. So let's just go through these steps. How can we plot the point 120 degrees? Well, believe it or not, we're going to do the angle first. Okay? So angle first. Now I have some little help that I'm going to take this. First of all, stop. Let's look at my polar coordinate. Since I'm in degrees, I know this is 0 degrees and this is 90, 180, and so forth. So what are these tick marks in? 1, 2, 3. There's 6 of them, so that is every 15 degrees. So that's going to be 30, 45, 60, 75, 90, and so forth. So let's just label the ones that we're familiar with, and I think that's going to help a lot. Right, so we're going to do the angle first. So it's a little bit of help here. I'm going to take this and I'm going to rotate it to 120 degrees. Right, and then the second thing I'm going to do is I'm going to go now the radius. I want to count out 5. So let's see, I don't need it to go all the way out to here. Let's see, 1, 2, 3, 4, 5. That's where I want my point to be. Right? So that I've plotted that point. The arrow really doesn't have anything to do with it. I'm just showing you that you rotate and then you go out. Now I want 3 equivalent expressions for that point. Again, with a little magic, what you should do is you should take that arrow that possibly you've drawn and I want you to extend it. Okay, straight line. Then we're going to label some things. All right, so this is 120 degrees, but what is this angle? Well, remember a line is 180 degrees, so if I had 120 and I added 180, that would be 300 degrees. Now that's if you're rotating in a positive direction. But what happens if I say rotate it in a negative? Then what is this angle? I've gone backwards. How far? Well, remember it's in 15 degrees. So 15, 30, 45. That is negative 60 degrees. Another way you know if you're doing it correctly is that the absolute value of those two numbers, meaning make them both positive and add them together, they should always add up to 360 degrees because that makes a whole circle. So my next question is then what is the negative value for 120? Well, you could use the 360 and subtract 120 and say, that's 240, and it needs to be negative. Right? So now I've got 4 angles, and but you're going, but this is, that's not the same. But hold on. The radius can be positive or negative. I know this is confusing. Okay, so one name, of course, is 5 and 120 degrees. Another name would be 5 and negative 240 degrees. Because I would start at 0 and I would rotate it in the negative direction and be there. But what if the radius is negative? That's where we get kind of confused. How could we use a negative radius? Well, believe it or not, you're going to go in the opposite. So we're going to rotate to this angle, but instead of going positive toward that angle, all right, that would be a positive r, we're going to go backwards. Right, so we're going to still end up in the same direction. Let's go that again. What did I do? Rotated to 300 and then went backwards. And so the answer here would be -5, 300 degrees, and -5, -60 degrees. And all 4 points are the same point, plotted right here in polar land. Okay, so the positive r's, you can have a positive angle of 120 or a negative angle of -120. For the negatives, you're going to extend that line and say, okay, I'm not going to go toward 300, I'm going to go backwards. Very confusing. Now you can have an infinite amount of answers, but I want you to limit yourselves between where r is positive and negative, and that theta goes between -360 degrees and +360 degrees. So let's see if we can do this problem. Well, again, it might help to kind of label where 210 degrees is. Remember, this is 90, and so this plus 30, well, this is 180, plus 30, this is 210 degrees. So I want to take and think about rotating all the way here. Oh, but how can I don't want to go toward 270 because r is negative. I have to go backwards. 1, 2, 3, 4. And this is my point. Okay, so think about extending that line toward 210, but I didn't go 1, 2, 3, 4. No, I went -4. Again, pretty confusing. So again, I want 3 equivalent expressions. So what I would want you to do is go ahead and label basically that line. Label the endpoints with your angle. So you know that's 210. What's the negative angle? Think about 360 subtracting, and that's -150 degrees. So that's those 2 angles. Then what's over here? Well, you should know that's 30 degrees or -330. Again, checking the absolute value of those 2 numbers should add to 360. And the difference between the positives should be 180 degrees because it's a line. We're going to have a -4 and an angle, a +4 and an angle, and a +4 and an angle. All right, so let's do the negative. So -4 and 210 was here. Well, what else could it be? -4 and -150 degrees. Again, because I rotate toward 150, but I have to go in the opposite direction because of the -4. Now what about the +4? +4 means I'm going to go in that direction. How do I get there? I want to use those angles. And what are those angles? 30 degrees and -330 degrees. Confusing? You'll get better at it. So just when you think you got better at it, now I'm going to do radians. All right. Let's label these with radians. Ooh, we've got a -π/3. Well, remember, this is π/2. This is pi. Remember 30 degrees is π/6. 45 is π/4. And this is π/3. So you can either convert that to degrees, however you want to do, but your answers need to be in radians here. So -π/3 is there. So I'm going to go ahead and, all right, so if I take this, rotate it toward -π/3, and I want to go 1, 2, 3, 4, 5. All right, so that's the point that I want. I want to extend that, and these are the angles I need to label along here. So let's do the math. So instead of 360 degrees, we need 2 pi. We need a positive angle and a negative angle. So this looks like the easiest one, right? So we pi over 3, pi over 2. This is 2 pi over 3. What's this one in terms of positive length? This is 3 pi over 2. What is that? Couple of different ways you can get there. You can subtract from 2 pi, say 2 pi minus pi over 3, and that would be 6/3 pi minus pi over 3, and that's 5/3 pi. That's one way. You could have taken this number and added pi, because adding pi is the same as 180 degrees, and you're still going to get 5/3 pi. However your brain thinks about it. Okay, so now I need a negative angle here. So if I were to rotate in that direction, what would that angle be? Well, again, you can subtract it from 2 pi. So we would have, let's see, that's 6/3 minus 2/3. So that's going to be negative 4/3 pi. Okay, so now we have all of our angles. Right, so let's see, remember, this is my dot. So that was my one answer. So I need another one with positive and 2 with negative. Okay. So the one with positive, I'm going toward that. I want to use those 2 angles. And the ones with negative, I want to go away from that, and I want to use those 2 angles. All right, so the positive is going to be negative pi over 3 and 5 pi over 3. And the negative 5, we're going to use those 2 angles. So here I'm limiting theta between negative 2 pi and positive 2 pi. Let's see if we can do this one. Okay, so we've got negative 5 pi over 4. Where is that? Well, let's see. I know this is pi over 4. Right in the middle, let's see, that's 1/4, 2/4, so that's got to be 3/4 pi. This is 4/4. This is 5/4, 6/4, and 7/4. Remember, those are right in the middle. Those are those 45-degree angles. Right now, but it's a negative 5/4. That means I have to go in the opposite direction. Let's see. That would be negative 1/4, negative 2/4, negative 3/4, negative 4/4. That would be negative 5/4. All right, but look, do I want to go toward that? No, I've got to go away from that. 1, 2, 3, 4, 5, 6. So that's my dot, believe it or not. What did I do? I rotated negative 5/4, right? Went all the way to here, but I had to go backwards. So that tells me that this is negative 5/4. Let's just check out that math. How did I get there? Well, I counted in terms of fourths, but you could also say 2 pi minus 3/4 pi, so that's just doing the math. Remember, their absolute value has to add up to 2 pi. That's a whole circle, so that's how I get those 2 numbers. And so that's 7/4. Well, I just need 1/4 for 8/4, so that's got to be negative. This was the given value. So I need another one. If I used the negative 5/4 pi with the negative 6, then I also want to use the positive 3/4 pi with the negative 6. Because what would that be? I would be rotating here, but instead of going toward that, I'm going in the opposite direction. And now with the positive, I want to use these 2 because I'm going toward those angles. Okay, that's really a 7. Okay, so we have 7 fourths pi and negative pi over 4. And those are my equivalents in radians because that's what I started out with.